Okay guys, in this section 12-8 we're looking at scale factor and ratios, and this word ratio, it's just another way to write a fraction. So in other words, if your fraction is 2/3, the ratio would be 2 to 3. Alright, so a ratio is just another way to write a fraction is all it is. And also remember, scale factor is always new over old when you're talking about the scale factor as to how many times bigger or smaller the figure got, the new figure over the old figure. And so what we're going to do is we're going to relate how the different ratios of the surface areas and the volumes relate to two figures. Okay, so like for example, here's a chart that can kind of help give you the relationship. If the scale factor is A to B, right? 2 to 1, 3 to 2, 3 over 2, whatever the scale factor is, then the ratio of the perimeters is A to B to the first power, meaning it's exactly the same. The ratio of the perimeters of the figure, it would be exactly the same as the scale factor of the figure. Okay, the ratio of the areas would be A squared to B squared. The ratio of the volumes would be A to the third power to B to the third power. Alright, and so here's what we mean by this. Let's say we have these two figures, right? And the first thing I want is the scale factor. Well, scale factor is new over old, right? And so all I have to do is take one of these and put it over the matching of the other. So let's do 42. Since that's the biggest, we'll put it over 12. So 42 over 12, all right, that can be reduced to 7 over 2 if I reduce the top and the bottom by 6. All right? And of course the ratio can be written like this, 7 to 2. The ratio is 7 to 2. All right? So 7 over 2, this one is 7 over 2 times as big as this one. And 7 divided by 2 is 3.5. So we could say this figure is 3.5 times as big as this one. That's what the scale factor tells us. But as a ratio, it's 7 to 2. Now, I can use this scale factor to find the ratio of the surface areas by just taking that scale factor and raising each part of it to the second power. Surface area, ratio is the scale factor to the second power. So all I've got to do is take 7 squared, right? The ratio of the surface areas would be 7 squared to 2 squared. Well, what is 7 squared? 49 to 2 squared, which is 4. All right? So once you have the scale factor, all you've got to do is raise it to the appropriate power to get the ratio of the areas and then also the ratio of the volumes. Well, the ratio of the volumes would be 7 to the third power to 2 to the third power, right? And again, so the ratio of the volumes is going to be the ratio of the scale factor, both parts raised to the third power. So 7 to the third power would be 7 times 7 times 7. Let's see what that is. 7 times 7 times 7, 343. 343. 2, and then 2 to the third power is 2 times 2 times 2, 8. All right. So even though the figure itself is like 3.5 times as big, when you're talking about the volumes, though, it's 343 divided by 8, which is 42.8, almost 43 times as big. So if you make the figure 3.5, the dimensions 3.5 times as big, the volume is almost 43 times bigger than it was before. So it's a significant difference. All right. A couple more questions. It says, suppose the area of the small prism is 48. Find the surface area of the large prism. So let's say it had the same scale factor, right? And the surface area of the small prism was 48. What would the surface area of the large prism be? Well, we can find that with a simple proportion. We're using area, so I'll use the ratio of the surface areas, which is 49 over 4, right? And I'm going to set that equal to, now, x, which is what I'm trying to find, okay, over 48. Okay? And so again, the surface area of the small prism is 48. That means 48 has to go on the bottom because the small number in the ratio is on the bottom, right? So if this had said large prism was 48, I'd put it up here with a large number and make the bottom x. But since it says the small prism is 48, that goes with the small number on the bottom. And now we just need to cross multiply and solve the proportion. So 4 times x is 4x. 49 times 48 is 2352. So we're just doing the cross product there. Now I'm ready to divide it by 4. And when you do, you're going to get 588. 588. Okay, so there you go. Now, if you wanted to make sure that that was correct, then 588 divided by 48, okay, should be equal to 49 divided by 4. Okay, and if it is, then you know you did it right. So that's a way to double check it. Okay, what about the next one though? Suppose the volume of the large prism is 2744. Find the volume of the small prism. So I need the volumes this time, the ratio of the volumes, which means my first fraction is going to be 343 over 8, and that's going to be set equal to the large prism. The large number's on top, so the large prism number has to be on top here, to 2744, and we're going to put that over x. And once again, I've got a proportion that I need to solve here. Okay, so we'll do the cross product. That's 343x is equal to 8 times 2744. That's 21,952. 21,952. Divide 343 both sides, and we get our x is equal to 64. Is your correct answer. Okay. Let's try another one now. So again, I've got two prisms that I'm looking at. I'll need to find the scale factor. So I'll set it up with the one that's not a decimal number here. So new over old, that would be 20 over 12. And so that's going to reduce to 5 over 3. And so the scale factor is 5 to 3. That's the ratio. All right, 5 to 3. Which, if you divide that out, would be 1.66 times as big. Find the ratio of the surface areas. Well, remember, to turn this into surface area, I've got to square both of these. So that would be 5 squared to 3 squared. And then that's 25 to 9. All right, so that would be the ratio of the surface area. The ratio of the volumes would be scale factor to the third power, 5 to the third power to 3 to the third power. And 5 to the third power is 5 times 5 times 5, which is 125. And 3 to the third power is 3 times 3 times 3, which is 27. So here's the scale factor. Here's the ratio of the surface areas, the ratio of the volumes. So if you do scale factor correctly, all you got to do is raise it to the appropriate power. But be careful, if you mess up on scale factor, it's also going to throw these two off. So watch out for that. All right, so suppose the area of the large prism is 450. Find the surface area of the small prism, provided that the two have the same scale factor is the premise here. All right. So first thing I'm going to do is write out the ratios for the surface areas, right? And that's going to be my first fraction, which is 25 over 9. And I need to go ahead and set that equal to now the information from the problem, which the surface area of the large prism is 450. And so where does the large number go in my proportion? On the top. And x will be on the bottom, and then that will be the small prism. So 25 times x, 25x. We're just doing our cross product here now. And so 9 times 450. 9 times 450 is going to be 4050. All right. Let's divide it by 25 here and 25 here. And we're going to get x is equal to 162. All right. So again, it's all about picking the right proportion and then setting up the other fraction correctly. Suppose the volume of the small prism is 24. Find the volume of the large prism. I need to start with my first fraction, which is the ratio of the volumes. 125 over 27, and I want to set that equal to small prism 324. So where's the small number in my proportion? It's on the bottom, right? 27 is smaller than 125, so that means 324 has to go on the bottom because it's the small number, and the large prism is the x. So that would be then 27x equals 125 times 324. That's going to be 40,500 divided by 27, and then so we can get x is equal to 1,500 will be your correct answer there. All right, so that's it.